To remain below 2 degrees centigrade by 2100, most projections argue that the world will need to find a way to achieve negative emissions. Actually, the national academies have run 3 consensus studies in this general area.
Excited to talk to you about carbon dioxide removal and also the work that we're doing at Department of Energy. The method of dealing with that scales with the size of the emissions on the order of gigatons is really geologic storage of CO2. We still need to, in parallel, advance and rapidly advance deep decarbonization methods in addition to scaling up CDR. Also looking at ocean carbon removal, we have 8 projects that we're funding so far, really at the early stages.
We've just completed a study of how long it's likely to take to develop, permit, and start operations for a sequestration well. The way we've done this is by identifying 6 clearance points that one needs to get through in order to get to the point of developing a well. One of the things we are working on now is trying to figure out some strategies that could safely speed the process. I won't read them since time is short, but we can move on now.
We basically see ourselves as a leading innovation in both in the technical sense, but also in let's say procedural sense. I will emphasize that our challenges are significant. As a country, methods of CO2 storage. This graph here shows essentially the time scale that CO2 can be stored on the x-axis. This mostly wants to show how broad the research efforts are.
So now we go back to academia and see how we spend the money from the federal ministry. So if we now add a new technology to the portfolio, the question is, can it actually reduce or remove emissions? So the purpose of the technology is met. That's the good news. However, what you see on the x-axis is the CO2 intensity of electricity. This is direct capture, an energetically and financially costly distraction. Yeah, maybe to some degree, but it's not total nonsense. But what we can conclude is it's definitely not the first thing that we should do. After we did all the reductions, so to make it more catchy, I would say reduce at best and then remove the rest. Net negative means we have to take CO2 from the atmosphere and store it somewhere else. I will just talk about 3 approaches that we wanted to do. So we have a DAC process. How does it look like? Well, we already heard about siting. So we have this container. Where do we put it? Yeah, we could put it in different places of the world, and that affects our process. Blue are the good places, so it's in places where it's cold and humid, something like Iceland. Yeah, that's where Climeworks put their DAC plants. They don't use wind power, they use geothermal. If we want to reuse renewable energy, we know it's fluctuating, so why should we operate our process in a steady state manner? So just by adding flexibility, we have to do a lot, and I just listed a lot of challenges that we have. And I think we have to find good business cases to really make it work, and the support by the right policies.
So what I would like to tell you about is a project that my partner Matthias May and I started investigating negative emission technologies based on photoelectrochemical methods. Our mission is to think about sustainable pathways under climate variability. The last time we were at CO2 concentrations that we are at today is at least 2 million years ago, might be even now. But here you can already see that our perspective is based on climate and on a detailed understanding of processes in climate, as well as a detailed understanding of materials and how they interact with light. Every single ton that goes into the atmosphere adds to global mean surface temperature, and this is because our natural sinks are slow and they are only adjusted to offsetting natural sources. It's important to note here that most of the mature technologies draw on natural photosynthesis for the fixation of carbon. We, in the project, have benefited from including social, ecological, and economical life cycle analysis, and this is important to ensure that we also include biodiversity, justice and equity in our future